Hey guys, this is the final video for term 1, or the first half of Precalc. We're actually a little ahead of where we usually are because this has been a longer term than most of the time. So we're going to start talking about how to get the unit circle and how to use the unit circle. But first I have a warm-up question. I'm a little leery that you're struggling with this idea. It says a Ferris wheel has a diameter of 30 feet. So Ferris wheel, you know, your little seats are all the way around here. Okay, get on the Ferris wheel. The diameter is 30 feet. For angular linear velocity questions, we always need the radius, so that would be 15 feet. I assume that's supposed to be rotates once every 48 seconds. So the time we're talking about is 48 seconds. Find the linear speed. So it rotates one rotation in 48 seconds. So one rotation per 48 seconds is almost an angular velocity, but remember angular velocity has to be in radians. So we have to say 2 pi radians per rotation. So now we have 2 pi radians per 48 seconds. And yes, that would reduce, but not too worried about it. And that's an angular speed. If we multiply the angular speed times the radius, we'll get the linear speed. So 2 pi over 48, that's radians per second, times a radius of 15 feet. Remember, radians magically disappear. So we have 30 pi feet per 48 seconds, or a linear speed of, and then we just type that in, 30 pi over 48 is almost 1.96, or about 2 feet per second. It's the speed at which it's rotating in feet per second. All right, moving on. This is review. We did this on another lesson, but I want to go over it real quick again. We used to help remember the signs of the trig functions. We start in the first quadrant, and we go to the second, third, and fourth, and I don't care if you use Roman numerals or not. And it's all students take calculus. This means they're all positive here. Only the sine and therefore cosecant are positive here. Only the tangent and therefore the cotangent are positive here. And only the cosine and therefore the secant are positive in this quadrant. All right, so using your knowledge of trig function, identify the function that is positive. In quadrant 1, they are all positive. I'm not going to list them all. In quadrant 2, sine is positive, and therefore its reciprocal cosecant is positive. Quadrant 3, tangent and its reciprocal cotangent are positive. Quadrant 4, cosine and its reciprocal secant are positive. All students take calculus, again, is the phrase. All right. Now, if we are using these symbols, I don't know why students have so much trouble with this, but this is saying cosine is, that's a greater than 0. So cosine is positive. Which quadrants could the terminal side lie? Well, if the cosine is positive, it could be in either quadrants 1 or 4. You can write those with regular numbers, I don't care. All right, this is tangent is less than, that is a less than 0. So the tangent is negative. Which quadrants could this be? Well, tangent is positive in quadrant 3, and they're all positive here. So that leaves tangent to be negative in 2 and 4. Secant is less than 0, okay? So the secant is negative, means the cosine, its reciprocal, is also negative. So which could that be true in? Well, it's positive here, so it can't be quadrant 4. They're all positive here, can't be negative here. But it would be negative in the other two because only sine and tangent are positive there. So it's negative in 2 and 3. The sine is less than 0 or negative, and the cotangent is greater than 0 or positive. That would be quadrant 3 over here because the cotangent is positive there and here, and the sine would be negative here. So I hope those are making sense to you. You need to practice that. All right, this next little section, I'm going to set these up, but I'm not going to necessarily find all these values. You can go back and look at the notes on the slides. I'll finish them after I finish the video. But this says the sine is 8/17 and the tangent is less than 0 or negative. So where is the sine positive and the tangent negative? All students, so that would be in quadrant 2. The sine is positive and the tangent is negative. So then we draw our bow tie triangle in quadrant 2 here. Now theta is actually the rotation all the way around to here, but we still use this reference angle to measure the function. The sine is y over r, or we haven't talked too much about that definition yet, opposite over hypotenuse. So opposite of that angle is here, hypotenuse is here. Now the hypotenuse, or the r value, is always positive. In this quadrant, the y value is positive, or the going up here. But when we do Pythagorean theorem, this is going to be a negative number because it's going left on the x-axis. So if I do leg squared plus other leg squared, I'll call it x, equals a hypotenuse squared, and then I subtract, I get 225, so x equals plus or minus 15. Well, because we went to the left, this is a negative 15. So then when we fill all these in, cosine is adjacent over hypotenuse. Whoops. Tangent is opposite over adjacent. Cosecant is the flip of sine. Secant is the flip of cosine. Cotangent is the flip of tangent. Okay, now we were in quadrant 2 where sine was positive. So the only thing that should have turned out positive was the sine and the cosecant. Everything else was negative. All right, so I did that one all the way through. The next two I'm just going to set up because they're just time consuming because they have radicals in them. This says the cotangent is negative 4, which would tell us right away if we flip that over that the tangent is negative 1/4. The secant is greater than 0 means the secant is positive, which means the cosine would also be positive. So where is tangent negative and cosine positive? All students take calculus. The cosine is positive in these two quadrants. They're all positive here, so that leaves tangent to be negative. We are in quadrant 4. So down in quadrant 4, we have a bow tie triangle, meaning with the x-axis. We're actually measuring all the way around here, but we use this to be our reference angle, and we're going to call it theta. This is tangent is opposite over adjacent, so this is adjacent over opposite, if you want to think of it that way. Okay, but when we do that, we don't know which one's negative. Well, adjacent and opposite are here and here. Which one of those is negative? Well, I went to the right 4, but down 1. So this is the one that's negative. Okay, the opposite is negative, or tangent, cotangent is also x over y. So the y value is the negative there. Then if I do Pythagorean theorem, the hypotenuse or the radius squared, I get 16 plus 1, remember this should turn out positive, is 17. And so the square root of 17 goes on that hypotenuse, and that's always positive. So these are going to turn out kind of ugly, okay? The sine is going to be opposite over hypotenuse, which becomes negative square root of 17 over 17, and so on. Okay, I'll finish that in the notes. You should try it before you check the notes. All right, then one more to set up. It says all students take calculus. We have the cosecant is negative, which means the sine is also negative because that's the reciprocal. Okay, so if we wanted to go over here and do the sine, we could put, and it would become negative 2 square roots of 5 over 5 when we rationalized it. It says the cosine is, that is a less than 0, so the cosine is negative. So if the sine and cosine are both negative, that means we're in quadrant 3. All right, so in quadrant 3, the cosecant would be the flip of sine. So this was sine. So cosecant is hypotenuse over opposite, or the sine is opposite over hypotenuse. Either way you want to think about that. But opposite here is a 2, and the hypotenuse is a square root of 5. That means which of those can be negative? Well, the hypotenuse can never be negative. This was down, so that is negative 2. But because we're going left on the x here, this is also going to be a negative. And that's what you have to figure out. All right, now if we do x squared plus y squared equals r squared, or leg squared plus leg squared equals hypotenuse squared, we get x squared plus 4 equals 5. Everybody with me here? Square root of 5 squared is 5. This is 4. We subtract, we get x squared equals 1. So x equals plus or minus 1. But we know it went left, so it has to be negative. So now we can find all the rest of these functions. So our angle was here. So like cosine is adjacent over hypotenuse, or negative square root of 5 over 5. Tangent is opposite over adjacent, which would be negative 2 over negative 1, or just 2, which makes cotangent 1/2. And secant is just the flip of cosine. So if we flip that right here before we rationalized it, we just get negative square root of 5. All right, so I finished that one for you. All right, the rest of the lesson is going to be on using the unit circle. So the unit circle, these definitions are extremely helpful, okay? I don't know if you have this exact thing in your notes or if we're going to put it in there, but I was trying to use these as we went. Sine is opposite over hypotenuse, but it's also y over r, and cosine is x over r, and tangent is y over x, and then you have those reciprocals. It's especially important when you're doing quadrantal angles that you know those definitions. Before we do that, I'm going to show you again how to develop the unit circle. These are the ratios you're supposed to have learned in geometry. So if this was 1, this was 1, this would be square root of 2 for a 45, 45, 90. If you have a 60, 30, 90, 30, 60, 90, the hypotenuse is 2. If x is 1 here, if the short leg is 1, and across from the 60 would be square root of 3. So I'm going to use those relationships. We'll come back to that slide to talk about how to find these. All right, the sine of 5 pi over 3. Well, I would really like it if you got used to thinking of pi as 180. So to change that to degrees, 5 times 180 divided by 3, well, 3 goes into 180 60 times, so 5 times 60, this is really the sine of 30 degrees. Sorry, 300 degrees. 5 times 60 is 300. So if I measure around 300, then the remaining reference angle, remember to the nearest x-axis, is 60 degrees, always positive. But down in this quadrant, the y value will be negative. So it's a 60. So opposite there is a square root of 3. Short leg opposite of 30 is 1. Hypotenuse is 2. If you just remember what I just put on that last. So this is not a unit circle, because in the unit circle, the radius is always 1. And eventually we're going to get to that. But I just want to show you that this is why it works, because of the 30, 60, 90 rules. And we did go down to get to the y, so that's negative. Now the sine is opposite over hypotenuse, or y value, because this was up and down, that's the y, over r, and this is the x. So we have negative square root of 3 over 2. But this takes a lot of time. I'm going to do a couple more this way, though. Cosecant of 210, okay, 210 degrees is past 180 by how much? So if we subtract 180, we get 30. So this is a 30-degree angle. So the short leg is 1 across from the 60. The long leg is square root of 3. The hypotenuse is 2. But remember, we went left, so this is negative, and we went down, so this is negative. Should have used a different color from the beginning on this one. All right, so cosecant is the flip of sine, reciprocal of sine. So sine is y over r, or opposite over hypotenuse. So cosecant is r over y, or hypotenuse over opposite. So hypotenuse is 2, or the r value is 2, over the y, or the opposite, is negative 1. So we just get the cosecant of 210 degrees is negative 2. All right, no unit circle. I did that from my memory of the 30, 60, 90, 45, 45, 90. One more. Cosine of negative 315, if you went around this direction, 315 degrees, which would make it negative, the remaining to 360 here would be a 45-degree angle. Reference angle, should know how to find those, which makes this a 45, 45, 90. So these are the same. And then if you do Pythagorean theorem, this would be square root of 2. Now, cosine is just adjacent over hypotenuse, or x over r, which simplifies to square root of 2 over 2. I didn't write that so that there's room. All right, but we're going to talk about how to do these much faster if you use a unit circle. And normally we would have a, you would have to memorize the unit circle, and we'd have a quiz on the unit circle, but I can't really do that this year, so we're just going to work on familiarity with the unit circle. If you're going to calculus, super important that you memorize it. All right, sine here, if this is an x distance across and this is a y distance up and down, when we use our usual opposite over hypotenuse, it would be y over 1, or y over r. Okay, if we're using a unit circle, this is just the y value because the radius is 1. Cosine definition is adjacent over hypotenuse, or on our picture, x over r. If it's a unit circle again, it's just x value will give you the cosine. Tangent, more complicated. Tangent is opposite over adjacent, or y over x. Okay, that doesn't simplify, so you're going to have to put those values over each other. When you flip this over, cosecant would be radius over y value, okay, which the radius is 1, so it is the reciprocal of y. All right, so you're flipping the y value over. I hate to write it as 1 over y because it gets complicated. Just remember it's the reciprocal of y. Whatever the y is, you flip it over. Secant is the flip of cosine, so it's the radius over x. Because the radius is 1, it's just 1 over x, or the reciprocal of whatever the x value was. The cotangent is the flip of this, so it's just x over y. All right, the coordinates of any point on here can be written as x, y, but x is cosine and y is sine. So we are going to use this unit circle to tell us the cosine and the sine of any functions. Now, to do tangent, I'll go back and talk about this slide real quick. Whenever you have a function, or whenever you have values that you're dividing fractions, remember you flip the second one over, so this becomes 3/4 times 4/7. The 4's can divide out and we get 3/7. Whenever you have square root of 3 over 2, you're dividing by a -5/2. It means you're multiplying by the reciprocal. The 2's will divide out and you'd get square root of 3 over -5. Now, what I'm trying to show you here, the reason I put these in is when these denominators are the same, they divided out. When these denominators were the same, they divided out. So as long as our divisors are the same here, when we are dividing, we get this number over this number as our answer. That's going to be really important when we do tangent on the unit circle. All right, so we're going to fill the unit circle in. First, remember we've changed the radius to 1. So all the way over to here is 1 unit. So this is going to be over 1 and up 0. Now, as you go around, this is a 30, 60, 90. So this is 30 degrees. So this would be short leg, long leg, hypotenuse. But we have divided everything by 2 to make it a radius of 1. So this is a longer distance, which is square root of 3 over 2, and up a shorter distance, which is 1/2. All right, we're going to move on and do these this way. All right, so I went over a longer distance and up a shorter distance. The y value is a shorter distance than obviously this x value. When we get to the pi over 4, remember that's a 45, 45, 90. So these two legs are the same. Now normally we do 1, 1 and square root of 2, but because we want the radius to be 1, it becomes this. So 1 over the square root of 2 is square root of 2 over 2, square root of 2 over 2. If you can memorize these 4 numbers right here, you have most of the unit circle done. All right, now this triangle is just the green one that we did over here flipped around. It's now a shorter x value and a longer y value. Hope that makes sense. And then this is a unit circle, so this is a distance of 1, so we went over 0 and up 1. Okay, sorry, wrong way. This was over 0 and up 1. This one is going to be straight over 1, negative, and up 0. Now, this, again, is the 30, 60, 90 with a reference angle in here of 60. So look, I went over a little bit, but I went left, and up a lot of bit, square root of 3 over 2. This is a 45, so I went over the same amount both times, square root of 2 over 2, up square root of 2 over 2, but I went left, so it's negative. This one, I went over longer and up shorter, so I went over square root of 3 over 2 and up 1/2, but the up is positive and left is negative. All right, down here, again, we went left 1 and up 0. This one is across 0 and down 1. All right, this I went over further than I went down, so I went over square root of 3 over 2 to the left and down 1/2. If you want to do this at the same time, this one went over a little but down a lot further, so over 1/2 and down square root of 3 over 2. And the 45, 45, 90 in the middle here went over the same amount as it went down. Those are the same, so it's square root of 2 over 2 and square root of 2 over 2, but I went left and down, so they're both negative. All right, last quadrant. Same thing here. I went across 0, down 1. This one was over 1 and up 0. Okay, in this one, I went over a lot, down a little. Now I went to the right, so that one's positive, but I went down, so that one's negative. 45, 45, 90 is always square root of 2, over 2, and square root of 2 over 2, but I went to the right and down, so that one should be negative. And then this one, I went over a little, but down a lot, so it is a 1/2 to the right and down square root of 3 over 2. That's how I keep them straight. All right. One more time, we're supposed to do all students take calculus. So all of them are positive. The sine and its reciprocal are positive. The tangent and its reciprocal are positive. The cosine and its reciprocal are positive. Oh, this is saying sine is the x value. Just kidding. Oh my gosh, that would have been really bad. The sine is the y value. Cosine is the x value, and tangent is you put the y over the x. Cotangent is the x over the y, and cosecant is you flip the sign, so it's really just reciprocal of the sine of the y value. And secant is 1 over x, or the reciprocal of the x value. All right, so these are the things you got to know so that we can use the unit circle effectively. I want to practice tangent. Remember, we just did that dividing fractions thing. I'm going to show you what happens. If you go to 5 pi over 3 on the unit circle, so that's pi over 3 would be 180 over 3 or 60. So we're going to 300. So we'd be around over here at a 60-degree angle here. So you went over a little and down a lot. That's the way I remember that. Okay, that's where they got this ordered pair. And then tangent is y over x. Now if I put the y value is divided by the x value, and then I flip it over, these will divide out, and I get negative square root of 3 over 1, or just negative square root of 3. But remember, I told you, as long as the denominators are the same, they're going to always cancel out. So I really, really, really want you to learn that when you're doing tangent, it's just this y over this x, the top. Negative square root of 3 over 1, so we get negative square root of 3. So much faster than worrying about all this. All right, the denominators will always cancel. And here, remember, it's cosine, sine. All right, so we're going to use the unit circle to find these values. 7 pi over 6, you need to familiarize yourself where these are. A pi over 6 is 30, 7 of them would be 210, so it's down here. So we're looking at this ordered pair. The cosine is just the x. Easy peasy. So the sine at pi is here. So if you can remember that you want left 1 and up 0, the sine is the y value, so that's just 0. All right, cosine was x. I should be writing these down. Negative square root of 3 over 2, negative 1/2, and we just used the x value. The sine was at negative 1, 0, and we just used the y value. All right. Secant of, ooh, they're trying to trick us already. First of all, it's secant, so we're going to have to flip something over, but second of all, it's negative 3 pi over 4. Well, if you look here, pi over 4 is a 45, or if you look here, 3 pi over 4 is here. So a 3 pi over 4 normally is one quadrant and halfway through the next, but we're going to do that in a negative direction. So we're going to go negative 1 quadrant and to the middle of the next. So we are here. The ordered pair is negative square root of 2 over 2. Okay, so we measured 3 pi over 4 and saw where it was, but then we had to do that same thing in the negative direction. Then we wrote down the ordered pair. Now, secant is the reciprocal of cosine. So remember, I kept saying it's hard to do 1 over, because what you're saying is this is 1 divided by negative square root of 2 over 2. If you just remember, you flip the cosine, it becomes 2 over square root of 2. Now, if you memorize these, it helps. But what happens when you rationalize this is you get negative 2 square root of 2 over 2, which is just negative square root of 2. So if you can remember that anytime you flip over square root of 2 over 2, you just get square root of 2, that helps. Otherwise, it's a lot of work. But you're flipping over the y value, the x value, because secant is the reciprocal of cosine. Sorry, you were doing that one. Cotangent of 270. Well, 270 is right down here. So we have the ordered pair 0, negative 1. Cotangent, you got to memorize this one. Cotangent is x over y, so it's 0 over negative 1. Guys, I cannot tell you how important it is right now that you know when you have 0 over something, you can divide on your calculator if you need to, but you should get 0. When the 0 is underneath, it's undefined, okay? So if you have a number divided by 0, that's undefined. But if you have 0 divided by some number, you get 0. Make sure you know that. Man, I get so frustrated when students get those backwards or wrong or whatever. Use your calculator if you have to. It'll give you an error if you try to divide by 0. All right, tangent at pi over 2. Tangent, remember, is y over x. Pi over 2 is here. The ordered pair is 0, 1. So the y value over the x value would be 1 over 0. This is y, this is x. And we just said division by 0 is undefined. Please literally write undefined, okay? Sine of negative 240. Well, again, it's a negative angle, but if you look for the positive 240 first, it's halfway around and to here. So we're going to do it the opposite direction, halfway around and another 60. Or you could just add 360. And it's the same as the sine of 120, if that makes you feel better. So we are looking at an ordered pair of negative 1/2 square root of 3 over 2. Well, sine is just the y value, so we're done. Cotangent, 4 pi over 3. Again, it helps if you know where to look. A pi over 3 is a 60 degrees, so 4 of them would go around to here. So we're at an ordered pair of negative 1/2 comma negative square root of 3 over 2. Well, cotangent is, tangent is y over x, so cotangent is x over y. If you want to write it all out, remember it's this, x over y. But I told you the divisors are going to go away, so I'm going to end up with the x numerator over the y numerator, which is just 1 over the square root of 3, which rationalizes to square root of 3 over 3. This is probably the hardest one when you have that mess, okay? But it's the y, okay, yes, cotangent is x over y. So it's 1 over square root of 3, which rationalizes to this. So most of you will get it eventually, so you only need to do maybe those 2 steps. All right, tangent of negative 60. Negative 60 would be here, 300. So the ordered pair is 1/2, negative square root of 3 over 2. And then we're going to talk about tangent, so we need y over x. This one was x over y, remember? Y over x is just going to be negative square root of 3 over 1 or negative square root of 3. Because remember, the divisors will always, if you write it out, y divided by this and flip it over, they will divide out. There's no point in doing all that work. All right, tricky because it's negative again. You could change it to degrees. Look on here and go 5 pi over 4 is 225. It's negative, then add a 360. I just go, okay, 5 pi over 4 was halfway around and another half a quadrant, but I'm supposed to be going negative, so it would be halfway around and another half a quadrant. Use your symmetry. So it's here. Cosecant is the flip of sine, so I'm using this one and I'm supposed to flip it over. Do you remember what happens? It just becomes square root of 2. All right, a lot of work if you can just memorize that when you flip the square root of 2 over 2, it's just square root of 2. All right, cosine, oh, another negative. What's with all the negatives? All right, if I look here, 2 pi over 3 is 1 quadrant and 1 more little angle. So if I go negative, 1 quadrant and 1 more angle, I am down at this ordered pair, which is cut off for me a little bit. That's okay. I'm going to talk you through this because we went over a little and down a lot. So we went over a little and down a lot. Now, I will move the slide up to show you, but I'm trying to help you practice where these ordered pairs are. Okay? Cosine is just x. So we're done. Answer negative 1/2. Oh, easy one. 135 is right here. The ordered pairs, negative square root of 2 over 2, positive square root of 2 over 2. Sine is just y value. So there's your answer, square root of 2 over 2. Tangent, 5 pi over 6. Easy one again, except it's tangent. Tangent, remember, is y over x. So we get 1 over a negative square root of 3, which is negative square root of 3 over 3. Secant, okay, we got to flip cosine. So this is reciprocal of cosine, or 1 over x. Let's flip the x over. Now, negative 11 pi over 6. Well, if you go around here, 11 pi over 6 is right here. So it's all the way around except one little ordered pair. But we're supposed to go negative, so we'd go all the way around except one little ordered pair. So you can change these to degrees, guys. If you want to change that to a 180, do negative 11 times 180 divided by 6, then add 360, you'll get 60 degrees or 30 degrees, and you'll be right here. Same difference. Okay, so anything that helps you figure out where that is. So this is our ordered pair. The cosine is here, but we're supposed to flip it over. So we get 2 over square root of 3, which becomes 2 square roots of 3 over 3 when you do the whole square root of 3 over square root of 3 thing in there. Okay? Not an easy one necessarily. All right, cotangent, also not super easy, but we can do it. 5 pi over 3, goodness, they're happy with these negatives. 5 pi over 3 is 3 of these around and 1 more ordered pair. But we're supposed to go negative, so it's going to go 3 quadrants around and 1 more ordered pair. It's here. Or you could have said 5 times 180 divided by 3, would make that 300. And then you add 360 and you get a positive 60, and it's at that spot. Whatever helps you figure out where it is. When it's negative, they're just miserable. Okay, 1/2 square root of 3 over 2 is the ordered pair we're working with. Cotangent is x over y, so we have 1 over square root of 3, which is square root of 3 over 3. Last two? Nope, we're done. All right, so practice the unit circle, practice using the unit circle. I have several ways for you to do that. Are we done, done? Oh, this is just a couple quadrantals. You should really have these memorized. If you're down here at 270, you went over 0 and down 1. Cosecant, I'm sorry, this says cosine, so it's just 0, the x value. Pi over 2 is up here. Again, memorize where that is. Pi over 2 is over 0 and up 1. Cosecant is the reciprocal of sine. The sine was 1, so the flip of that would just be 1. Cotangent of negative 90. Well, negative 90 would mean you went to here. Ordered pair is still negative 1. Cotangent is x over y, so it's 0 over negative 1. Which is 0. Okay, if it had asked for tangent, it would have been undefined, because you would have had negative 1 over 0, which would be undefined. All right, just a little more practice. All right,